do by the end of the lesson is you need to be able to describe exponential growth versus decay. So like in the problems on the quiz, it won't necessarily tell you which one is which. You have to be able to tell. You need to be able to solve real-world problems using the appropriate formulas, which we will go over together. And you need to be able to identify each piece of the formula, which we will also go over. All right? Exponential growth has a specific formula, and I don't think I'm going to make you memorize it, but you do need to know how to use it. So it's y equal to a times the sum of 1 plus r to the t power. All right? Oops. Y equal to a to the 1 plus r to the t power. Right? And in this case, a means initial amount. All right, so you'll see in these problems, a lot of them have to deal with money. So the initial amount would be what you're starting with. R represents growth rate. And this needs to be in your formula as a decimal. Right? So your growth rate, and it needs to be represented as a decimal. And then T stands for time. All right, if you have some colored pens or highlighters, I'd pull them out and use them for these, because when I'm going through the problems, I'm going to highlight the initial amount in yellow. I'm going to highlight the growth rate in green. And I'm going to highlight time in blue. All right, just so that you can see it in the problem. Because really the hardest part is just seeing which of these numbers represents which of these. All right? So the first question, anyone want to read it out for everyone? Haley?
The original value of an investment is $1,400 and the value increases by 9% each year. Use an exponential growth function to find the value of the investment after 25 years.
All right, perfect. So then now we're just identifying each little piece of the problem, what each number represents. So what number in the problem is going to be my initial amount?
1,400.
1,400. All right, that's what we're starting with. So that is my initial amount. What about the growth rate?
9%, so you had
It's 9%. How would I represent that as a decimal?
0.09.
0.09. Good. Don't get confused. Like some people would think it's 0.9. All right, that would be 90%, not 9%. All right. So think of it kind of like out of 100, so like pennies maybe, or like as a dollar. So 100 would be 1.00, and then 9%, so like 9 pennies, would be represented like this. All right. So 9%. Is our growth rate, which is 0.09, and then our time would be
26 years and after.
25 years.
Whatever.
All right, and then now you could rewrite the formula every time if that helps you, but we're just plugging into the formula. So A, our initial amount is 1,400. Times the sum of 1, and it's always going to be 1 because that's in the formula, plus the growth rate, 0.09, and to the t power, which t is 25. All right, and then now for this, we are just going to continue solving by entering it all in the calculator. So you can enter the whole thing in the calculator at once. You don't necessarily have to break it apart. So you can enter 1,400, parentheses, 1 plus 0.09, parentheses, and then hit that exponent button to the 25 power. All right, so everyone needs to try that out in the calculator so that I know you know how to do it. calculators will work. It doesn't even have to be a scientific calculator. Alright, so practice entering the entire thing into the calculator, exactly how it looks up there. Alright, so then if we entered it correctly, we should have gotten what?
12,072.31.
Alright, everyone else get this? Alright, if you didn't, just let me know. It could just be maybe you forgot your exponent or something like that. Just let me know. I can look at your calculator and we can figure out where we went wrong. Alright, but that is the correct answer. Alright, and it is a dollar amount, so I put the dollar sign there. And we round using our normal rounding rules to the hundredths place. Questions on 1? Alright, I'll walk you through 2 and then we'll try one on our own. So then number 2. Anyone want to read it? Someone different this time? Alright, Jay, go ahead.
The cost of tuition at a college is $12,000 and is increasing at the rate of 6% each year. Use an exponential function to find out tuition cost after 4 years.
Alright, great. So I know you guys probably don't know that much about interest rates right now at this stage in your life, but 6% is kind of a lot. Alright, especially if the tuition is already $12,000. Alright, so enter it into the formula, so you need to identify which is which. So what is the initial amount?
12,000.
Alright, 12,000. The growth rate?
6%.
6%, and the time? Alright, 4 years. Alright, so enter it in your formula. So y equals a, which is 12,000, times 1 minus, or sorry, plus r. What is 6% represented as a decimal?
0.06.
Good. 0.06 to the 4th power. Right? So then, put that whole thing in the calculator. You don't necessarily have to break it apart, because the calculator does order of operations for you. Alright, give everyone a chance to enter it before we see the answer. Everyone get a chance to enter it? Alright, what did we get?
15,149.
Alright, perfect. Any questions? Do we need to revisit the rounding rules? Or do you think we have that down? Alright, just in case. Alright, if we, I can't remember what it was exactly in the calculator. What was it at this point?
I think it was a 3.
It was a 3 over here.
Yeah.
So if we're rounding to where it's like a dollar amount, so here's like my cents. Alright, we know we never write cents as 0.723. We round it to 2 numbers. Look at the number that is next to the last number that you want in your final answer. So looking at the number to the right of it is a 3. So if it's between 0 and 4, it stays the same. Alright, so because it's 3 and that falls in that region, it just stays as 0.72. Alright, but if it were a number from 5 through 9, then we are rounding up. Alright, so just in case. Now go ahead and try to keep working down the page. We'll go over number 3 in 2 minutes, but try to keep working down the page. And then we're gonna flip to the other side so that you can see some exponential decay. Flip over to the next page and look at some where instead of increasing, we're going to be decreasing. Alright, because remember that's what decay is decreasing. Alright, ready to switch? Alright, so then exponential decay. So when something is decreasing at a very fast rate, so y, and it has a similar formula, but you'll see the difference. So the formula is going to be y equal to a times 1 minus r. Alright, to the t power.
Is it still like the same, like the A times you go to the same thing?
Yes,
Yeah.
except the r is a little bit different. So a is still going to be initial amount. And r, instead of being growth rate,
Decay rate?
yes, it's going to be decay rate. Alright, growth rate is for growth, decay rate is for decay. So the amount it's decreasing by, and then t will be for time. Alright, and I'll use the same colors as the first page. Alright, if you don't normally use colors or you don't have them, you can just kind of circle them and say this is my rate, something like that, or just make a list off to the side. Right? So, number 7, anyone want to read it? Josh, you looked like you wanted to read it earlier.
The population of the county is decreasing at a rate of 1% per year. In 2000, there were 1,300 people. A decent exponential function to find the population in 2008.
Alright, great. So then my initial amount is 1,300. So that's the amount I'm starting with. My decay rate would be 1%, so the amount it's decreasing by. And my time span is what? 8 years. How did you know? Alright, so we're looking from 2008 to 2000, well, 2000 to 2008. We subtract them, we get 8 years. Alright. Plug it into your formula and then plug it into your calculator. Alright, so y equals a times 1 minus r, don't forget that difference. So y equals 1,300 times 1 minus, what's 1% as a decimal? 0.01, and then to the t power would be, good.
I think they're the
Alright, two more time. Alright, what did we get?
1,190.
Alright, anyone disagree? Alright, that's good. Alright, because we're talking about people, we can't have a fraction of a person, so we just ignore the decimal part. Alright, questions? Alright, I think you can try number 8 on your own. So I'm going to give you some time to work on that one. We'll go over it, and then I'll explain what we're doing for the rest. Alright, so just keep trying to work down the page. If you already finished that one, keep working down the page. so from what I'm seeing, it looks like everyone has number 8 done. Alright, so we'll start going over it. The initial amount would be 18,000. Alright, that's the amount that they paid for the car initially. And it is depreciating at a rate of 12%, so that's our decay rate. So depreciating means decay or decreasing. And then the time would be good. Alright, put it in your formula, put it in your calculator. You have y equal to 18,000 times 1 minus, what's 12% of the decimal? 0.12 to the 10. Right? And then the value that we got was number 8. Alright, good. So that is how much the car is worth after 10 years. So even though they bought it for $18,000, right, after 10 years it's not worth that much anymore, it's only worth about 5,000. Right? So for the rest of the time, because it's a shorter day and I feel like you guys have this down, you're going to keep working to fill out the whole rest of this sheet. So all the ones that we didn't get to on the front and all the ones that we didn't do together on the back, you're going to work to fill them out. I'm going to come around with my clipboard, see how much you've gotten done, and that'll be your points for the day. Right, so I want to make sure that you have this down because tomorrow's worksheet will be based on this material. You asked me to go to the bathroom in the last 10 minutes. Okay, so 2.5, it's not going to be like 2.5, it's going to be 0.025. You're done? Do you have anything to work on? Any homework? I could give you a worksheet.
Do I have to? I mean, just 8 minutes. I mean,
Yeah. I could give you the worksheet for tomorrow. You can get a head start on that.
more work.
I know. Okay, so I'm gonna put the answers up in about 5 minutes, and then you can double check them.